When I was sitting here in the first row this morning, I was listening to all these exciting talks. I said, holy moly, well, how is this turning out this afternoon? Is that too trivial what I'm presenting to you? So I'm representing a German machine builder company who is doing the money with machines, with lasers, and we are enabling, you can read it in the press, with lasers, the semiconductor industry, so we are enablers for AI chips. And I would like to take you in the next 15 minutes on a quick journey, how we are using AI internally in our company, how we are transforming ourselves, how we provide AI to our customer to boost their efficiency and productivity, and last but not least, how we provide tools to create AI chips which will be implemented and integrated in the data center we discussed this morning. So let us get started. So I didn't know how to come across. First of all, my personal opinion, what I always tell to my employees is AI is not a threat. Yeah, of course, there's a lot of misuse which is possible, but it's definitely not a threat. It's maybe the only tool which we have today in our hands to come up with new solutions in a speedy way to the world crisis we are seeing. If you put into GPT the simple question, what's the biggest threats for mankind, you get a whole bunch of topics. You can read them behind, yeah. And this little gimmick should show it. We are way beyond COVID. We are talking now about climate change, although we forget about this in the face of the security threats what we are facing here in Europe. Biodiversity collapse is happening. Guys, we have so many topics out there, yeah, which need to be solved, yeah. And I believe this is only possible with artificial intelligence, with large volume of data centers and the storage capacity beyond it. So looking back in history of time, if we talk about innovation, and our company stands for innovation, we don't have time for innovation anymore. We are competing against China, we are competing against many things, we have so many topics, quantum, fusion, data center, KI itself, and so on. So if Thomas Edison said in those days, I didn't fail, but I just found 10,000 ways which didn't work, yeah, that's fine for him at that time when the speed of innovation was still slow. Today we don't have this. We need to earlier find out, to stay competitive with our companies and innovation, what will bring us forward and what ideas are going to fail. And this, from my perspective, can only be done by using artificial intelligence. So the next slide I'm showing you is very trivial, very fundamental. We all know that, yeah, that basically artificial neural network based on perceptrons is more or less the same as our brain, although I must admit I had a very good conversation yesterday evening. We don't understand our brain yet properly, but let's assume it would work linear by an interconnection of neurons or perceptrons, and we can say this is representing the intelligence. And what we did in the past, we heard this morning this nice example of the apple falling down from the tree, which made Newton thinking about gravity, which he came up with the nice formulas we all had to go through in undergrad physics. Yeah? If you look at the top, what did we do in the past? We were looking, observing the nature, building some interconnection by thinking, using our natural brain, our natural artificial, our natural intelligence, and came up with nice formulas. And then we applied these formulas to the real world. This is not working anymore when we face complex systems. First, we cannot access all the parameters in nature anymore. We have interconnected multi-physics, multi-events going on, where we can hardly understand the analytics. So going back now to artificial intelligence, where we use a neural network to make a pattern recognition and train these networks like a baby. A baby at the beginning doesn't know anything. If you put it in a box, which we shouldn't do, but if you put it in a box and leave it there, it is as stupid as it was born. Sorry for saying that. So it's a training. It's all a training effort, and this is where we can focus on in the future. How do we train these networks to get the proper results to solve all these problems I mentioned at the beginning? So of course Trump is not solving all the problems like diversity. We are too small for that. It's a global undertaking for human mankind. But what do we do? Let me quickly show you the figures we are doing. We are not infinitely large. We have about 20,000 employees doing something like 5 billion revenue with a decent EBIT margin for a machine builder, I would say, struggling a little bit with the economy right now. But here we go. These are our machines. We build everything to build flat sheet metals for car building, for kitchen building, for everything. The whole machine, laser cutting machines, bending machines, punching machines, whatever you need, we build the machines. And we build lasers, and those lasers partially go in those machines, and partially we deliver lasers also in the open market. So I don't know whether you know, but if you drive an electric vehicle, I show you later, consists of batteries, consists of electromotors. All these parts cannot be built without lasers anymore today. So and in every application we are seeing there, we today have artificial intelligence. Other topic I would like to mention, which is in the press out there, is extreme ultraviolet light, which we generate with our lasers. So our biggest and only customer for that is ASML. And ASML is a lithography tool provider for the smallest chip sizes you can have now. We are working now in semiconductor industry on the 2-nanometer technology. And we are the only provider of the driver source of these lasers. These lasers are monsters. They fill into 2 living rooms if you want. But with this, we are approaching data centers and many other topics. So quickly, and then it's enough here with key financial figures, where we earn the money and do the revenue. You can see it behind. So you see that the EUV business and the laser business by themselves joined together form a business beyond the 2 billion, almost getting close to 2.3 billion euros in that particular year. And when you go home and ask, there was a weird guy on stage talking a little bit of lasers on an AI conference, how can that be? But you can tell these are typical applications, what we are doing with lasers. So we are doing flat sheet cutting, welding, so joining together with welding, brazing, drilling. You see then this stand, yeah? So there we have particular lasers in which you can melt and cut plastics without, let's say, gluing them together or melting them down, and many other applications. So where do we do now AI? Coming to the point. Yeah. So first of all, we heard it this morning many times. For that reason, I can go quickly over the slides. You need to digitalize your entire company. Yeah, everything, all data, your machines, your processes, everything you need to have needs to be in digital format. That was a big transformation for us as a company, and we are not 100% through, but mostly. But then you need to storage the data very securely and need to make sure that you are not attacked by cyber attacks. And this is a data integration platform we have in Trumpf called DIP. And this DIP has all data. The data needs to be clean because we recall from this morning, without data, you cannot run any KI system and you cannot get then the artificial intelligence network trained, just FYI. So we have put our AI ambition in Trumpf on 3 major pillars, 1, 2, and 3. The one is our internal process digitalization. So where do we use AI there? We are using large language models, for instance, for our service application, service engineers. Think about a laser breaks down out there in the field, needs to be repaired. Yeah? The customer wants to have a quick answer. Typically, we have such a broad portfolio of products, the individual service engineer is already overwhelmed. Yeah? And we have applied ChatGPT, or we call it Blue GPT, to our internal DIP, which I showed you before, to our database. And by that, he very, very quickly can accumulate the relevant information to fix the topic. Yeah? But further beyond, we are also digitalizing our entire laser platform and our machines out there at the customers. So basically, we offer a connectivity link to our data integrator platform, and our customers store the data on our platform on which either we can run KI model to optimize their processes or check the condition state of their machines. In the worst case, or in the best case, doing preventative maintenance before the machine even breaks down, and so on and so on. Or the customer can even do it by himself. The second topic is a little bit a deep dive in which I'm going now for the second half of my talk. And the third, I don't have time, it's a speech by itself. That's basically the EUV lasers we are delivering to ASML for the lithography systems out there. So we think at least we are contributing somehow to AI. And now would like to show you how do we make our customers happy with AI. And it's about improving the overall equipment effectiveness. So the customer, if you have a machine on the shop floor, think about automotive electric vehicle builder, if the production line breaks down because you cannot build the batteries anymore, because you cannot build the motor anymore, and so on, I don't need to tell you things, you're in a shitstorm. Yeah? So rather, better this doesn't happen. Our customer is up for high equipment uptime. And the example I'm going to guide you through now in the next minutes, in the remaining minutes, is hairpin welding for electromotors. It's a rather simple example, but I think it makes clear in principle what we are doing. So we bring vision and imaging and vision detection by KI in the pre-process before we do anything. Yeah? So we look what parts need to be joined. Yeah? I explain you in a minute what you see here. Then we run the process in which we really weld and melt these parts together. And afterwards, we even inspect once more whether the weld was okay. You could imagine if the joints in such a stator field of an electromotor are not okay, your nice car, your BMW, your Tesla falls apart or doesn't drive at least anymore. We don't want to see that. And here we go. An electric vehicle, as you see it behind me, everything is done with lasers. The chassis is welded, the body in white is welded with lasers, and I'm picking here on one application down there, the hairpin welding. Yeah, you see what you see there in an enlarged picture is the motor, and the motor has an outer, let's say, stator field, we call it, which creates a magnetic field when we launch the current through it. And these are not coils anymore, as you know it from your Lego trains or so. Yeah, these are hairpin motors. That means we're putting some very, very strong copper parts in it, which are disconnected, so-called hairpins. Yeah, and they need to be now welded together very precisely to make the electrical conduction and also the mechanical strength. And if that fails, the entire motor fails as well. And what I'm showing you here now, exemplary, we do this in batteries, we do this in electronic powertrains, everywhere. And so first we start with an image acquisition of the hairpin you're seeing there. We tell the model, is the hairpin good? Are they properly oriented, or is it bad? If it's bad, we can tell them how the laser parameter needs to be adjusted, yeah, at the very beginning. So we train all existing conditions, and we apply the trained AI filter. We binarize the image, and then we execute the process. So you will see it in a quick video in a minute. How does the customer experience that? He has this laser and his optics and his process on the shop floor. He is taking all the images and tells all images here in the training process, in the cloud. He can go into the cloud and tell now and train and generate the AI model by himself without even being an expert of AI. He doesn't understand anything about AI. He uploads a picture and says, good, bad, good, bad, 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 good, and so on. You know how it goes. Then he downloads the whole thing back to his shop floor, and then it runs automatically, and everything will be welded automatically with 100% yield. And I hope I get this running here now. Yeah, there we go. It's 1 minute. Guess I'm running out of time a bit. One more slide. We're done. Yep. So here you see the optics with the laser attached, yeah. Here you see the hairpins of the motor, right? And now you have the detection. The model is trained. We have good ones, you have bad ones, a comparison to what has been taught primarily. Yeah? The customer can now say, okay, these are false parts, or these are good parts. Mark the area which is relevant, yeah, because the AI system doesn't know what a picture is, what it sees. Then he starts, there we go, activating the AI filter, and then off we go. 1 second, here we go. Yeah. And in practice now all this has been done, and now it starts welding. You see the laser beam welding these hairpins together, and once it's done, the entire motor is ready. And this goes at tremendous high speed. This has been slowed down that we can follow here with our eyes. Yeah? Running out of time, what I think is important for a company, for all of us, first of all, it's all about clean and consistent data. That is our experience. Without that, it doesn't work. You need to experiment early. yeah, to apply. Where does AI make sense? You need to get familiar, then you lose also the fear in doing it. But you should also make sure that you're not getting stuck in pilots. At some point, you need to have an overarching strategy. Yeah? Our approach is working in networks. We are not trying to reinvent the wheel, so we are talking to KI clusters. So I'm sorry, I'm from Swabia. Yeah, that's my disadvantage here today on stage. But we will start talking also to the Munich hub. Yeah. Utilize the speed and creativity of decentralization is my advice. We Germans are sometimes tending to centralization, which makes the whole thing slow because you're getting people involved who have no clue. And plenty potential remains, and train your employees. The vision of us, last sentence, is we will get for complete autonomous shop floors. There won't be any people. We have this already today where no material is carried along, but in the future, you won't even see people anymore who train the process. It's KI who runs the process and so on. These will be empty factories. Why are we doing this? We need to prepare for the gap of lacking labor in the future. Thank you very much.